But we would start with the first keynote that is going to be cause and effect relationship between the use of resources and the network status rating by Björn Dickenbrok of the DB InfraGO. And Björn, I think you have a presentation for us, so I will probably need to stop sharing mine.
Yes. Good morning, everybody. It's really a pleasure for me to speak to you at this online conference, and thank you to Ingo for inviting me. Like Ingo announced, my name is Björn Dickenbrok. I have been working for Deutsche Bahn since 2010, and I'm currently head of infrastructure condition evaluation at DB InfraGO. It's a quite new company. It's we have put together the two infrastructure managers for the superstructure and for the stations, the former companies DB Netz and DB Station and Service, and we made one company out of it called DB InfraGO, and that's a big company, the infrastructure manager company of Deutsche Bahn. And as you can imagine, the condition evaluation is really a frequently asked question, how the infrastructure quality or the infrastructure condition is at Deutsche Bahn and how it will develop over the next years. So that's the reason why I'm speaking today to you about the topic of establishing the cause-effect relationship between the use of funds and the network condition rate. My presentation will take around about 30 minutes and 30 minutes. And as Ingo already announced, we will have much room for discussion and questions later in the panel discussion. So let's get started. We will jump in and I will try to explain how Deutsche Bahn currently reports the condition of the infrastructure to the federal government. We have a report, it is called the Infrastructure Condition and Development Report. And on over 250 pages, there are a large number of contractually agreed KPIs are shown there. And there is shown the actual or the current value and the development over the last years. And like you can imagine, I just put on this slide some examples. It's really a kind of data overkill on over 250 pages. And the most important questions are, how is the overall condition of the infrastructure? What interventions are necessary? And how will the condition develop in the next years? And it's impossible to answer these questions with the current reporting. So that's the reason why we focused on evaluating the overall condition by building up a condition grade logic. And the idea of evaluating the condition by using condition grades is not new. It's already used in Austria, in Switzerland, and in Norway. The infrastructure managers there use it several years. So we had good examples to build up such a logic for ourselves. The grading scale, like you can see it on the slide, is from 1 to 5. And it is based on the German school grade system, the school rating system. So it is easy to understand, and it's quite intuitive. And the grade 1 means very good, and the grade 5 means bad or poor condition. And there is also a sixth grade. It is here called restrictive, and it is for special issues with short-term intervention needed. We have combined the condition grades with an indication of the need of interventions. You can see it below the grade scale. So the grades 1 and 2 means here is preventive maintenance perhaps necessary, or perhaps little reactive maintenance. And from the grade 3, reactive maintenance is necessary. Bigger interventions, maintenance interventions. And from the grade 4 to 5, we say it's the indication of renewal. So the technicians have to look if a renewal project has to be put on that assets, and we also call it the renewal backlog. So the goals of this new logic are, you can see it on the right side, it's a description of the overall infrastructure condition, the indication of the need for renewal and maintenance interventions. We also want to have a mapping of the infrastructure condition for any section. I will explain it later. The grade logic or the evaluation should be comparable for each asset type. The calculation of the cause-effect relationship between the use and funds and the condition grade should be possible. That means we want to use a prognosis on the condition grade logic. And we want to be able to calculate specific funding scenarios to reach a target condition of the infrastructure. And that is how it looks like at the moment. We have built up an additional reporting. It is a so-called network condition report. And it has approximately 50 pages, inclusive the condition of the stations. And like you can see in the bar diagram, the overall condition of our network is 3.03. That means it is adequate, but it's not the condition we want to have for our infrastructure. And in the next bars, you can see the asset types, the condition for each asset type. We have the superstructure. No, it's not the superstructure. First is this constructive engineering, bridges, tunnels, and retaining walls. These asset types are in better condition, in the roundabout very good and from very good to good. That means grade 1 and 2. Followed by the superstructure, tracks and switches and crossings in adequate condition, and followed by level crossings and signaling even in poor condition. And also the catenary in condition grade 2, I'm sorry, 2.87. And like you can imagine, or like you can see, the delay, the asset types that are normally responsible for delays, that means signaling, level crossings, switches and crossings, and tracks, are in adequate and poor condition. So that's the reason why the operation quality at Deutsche Bahn is what it is at the moment. So on the next slide, I brought a calculation map for the network condition grade for tracks. Like you can see on the downer line, we have defined the KPIs, the condition indicators, the relevant condition indicators for tracks. We have inspection messages from our SAP system, head check measures, inspection messages, rail defaults, track geometry measures. We are taking into account everything, every condition indicator that gives us an indication for intervention, for maintenance and renewal intervention. Also, the acute malfunction, speed restrictions, infrastructure failures, that means speed restrictions with a duration of more than 100 days. And also the remaining lifetime from our life cycle models. And the condition indicators are ranged for the quality dimensions, inspection, availability, and life cycle. And every condition indicator is weighted and calculated to an overall condition grade for the quality dimensions, and then aggregated to a total condition grade of each asset. That means one asset is one track section in this example. So, like I showed on the previous slide, we calculate an condition grade for each asset. And in the next step, it is possible to calculate an overall condition grade for network sections. So taking into account the condition grades of several assets and aggregate it to one overall condition grade. And it is always based on the condition of the individual asset. And it is aggregated to any network sections or asset types, or for the whole network condition, like I showed on the slide for the network condition report. The logic for aggregating the condition grade of several assets I brought on this slide. You can see 4 assets, a track section with a condition grade of 1.71, a bridge with 3.88, a retaining wall with 3.26, and a tunnel with 2.04. And the condition grades are now weighted by the asset value, and the asset value is normalized by the expected lifetime of the asset. So the condition grades are weighted by a kind of annual consumption of the asset value. And so we calculate a weighted average by this logic, and the average condition grade for these four assets would be 2.76. The condition grade logic is very new inside Deutsche Bahn. It is for us, it's really a new invention, but it already is established at Deutsche Bahn, and it is used for several application areas. Of course, for evaluating the network condition with a standardized grade logic that makes it possible to compare the condition of several asset types. We use it for internal reporting, for example, for dashboards that we can provide internally, and for external reporting, for example, with the network condition report, like I showed you. And it is also used to evaluate the need for renewal measures and also for maintenance measures. For example, for the general refurbishment corridors or for track sections, we can estimate the need for renewal. In this example, 60.5 kilometers of tracks, 5 switches and crossings, 3 signaling boxes, and 2 bridges. And we can put that into our planning for the renewal and for the planning of the possessions. And in my opinion, the most interesting part is forecasting of the infrastructure condition and the definition of target values. That's at the moment the overall question for us. How does the overall condition of the rail network in Germany will develop the next years, and will the funding that we hopefully get from our government, will it be enough to reach the target values? So, and that's what I would like to show you in the next step, on the next slide. We have on the one side the network condition grade method, like I showed you. We have a standardized evaluation. We have the possibility to aggregate the individual asset condition grades. We're taking into account the relevant condition characteristics. We have an indication for renewal and maintenance, and we have a kind of derivation of development trends from the history. But we want to look into the future. And that's the reason why we built up the so-called cost-effect relationships, or the models of cause-effect relationships. I'm sorry, here's just a Windows update popping up. I hope I can finish this meeting without installing the Windows update. So we built up scientific models for forecasting the development of the condition indicators. And we are taking into account the condition in the status quo, and we build up deterioration functions, and we build up the effect of renewal and maintenance measures, and put it into an combined both in one model. So we can automatically identify the renewal and maintenance interventions that are required. We have a kind of prioritization logic inside the model, and so we can forecast the deterioration of the condition characteristics, and the effect of the maintenance and renewal interventions. And that's an example from tracks. It's longitudinal track geometry failures. We took the results from the inspection of tracks and from the track measurement vehicles. And we determined the duration between the tamping interventions as a function of the age of the tracks. And we also clustered, of course, by speed and load. And we determined the deterioration curves using regression models. And in this example, it was the first approach we used is a linear regression. Difficult word. And like you can see, we have on the y-axis is a longitudinal track geometry failures, and it's first in the or initially in a good condition 0, and it deteriorates by time and by load and by speed as a train operations, and it will deteriorate until another intervention, a maintenance intervention, a tamping is done. It will be put to the good condition again, and then it will deteriorate again. But the speed of the deterioration increases with every tamping intervention. And like you can see in the clustering with the speed, the intervention cycles get more narrow, and also with the increase of the load. And that is how we model the prognosis of the condition grade. We first calculate the degradation, and secondly, we calculate the effect of measures depending on how many measures or not measures, how many interventions could be done. And that depends on the funding. So here, two examples for tracks. It's a first step, the deterioration of the track. Two examples with high load and low load. It starts with initial grade or the status quo condition grade, and like you can see, with low load, the condition deteriorates less than the track section with high load. And that's only the deterioration of the tracks. And in the second steps, we are taking into account the interventions, I'm sorry, and you can see from 2023 the deterioration to 2027, and now there are several interventions possible. First intervention is example for an intervention is the renewal. So the whole track sections is renewed, and it will be put to a condition grade 1, but not to 1.0 like you might have expected. We use as a kind of start value for new assets, to take into account that new assets can also have failures, and we call it the children diseases of new assets. And we are taking that into account by starting here after the renewal with a start value for the condition grade. Another possibility is to tamp the track section. It has not really a high effect on the condition grade. It just improves slightly, and it deteriorates further in the further years. And the red line shows the do nothing scenario. By 2028, I think a threshold is reached, and speed restriction have to be put on that track section, and so it deteriorates more, and even to condition grade 5, and deteriorates into an area where a renewal should be done, renewal should be done not immediately, but soon. So to summarize, the invented condition grade logic provides a transparent and intuitively understandable evaluation of the condition of the infrastructure. The condition grade is evaluated for each asset and can be aggregated for any network section, for example, for routes, for corridors, for regions. It is possible to forecast the development of the network condition depending on the use of funds. And it is realized by combining it with scientific models of the cause-effect relationship. It is based on the whole asset inventory, and the model is able to identify the need for intervention and the need for interventions in the future. Yes, and it is possible to calculate scenarios, specific scenarios for funding or for given amounts of renewal and maintenance interventions. So That's it. And thank you for listening.